E5 is about adding and subtracting rational expressions. Example 1. What is the least common multiple of 12x squared y, x squared plus 2x plus 1, and you can read the rest of it. I believe that's x squared plus 5x plus 4 in parentheses. Now, the key here is a factor, and the easiest way to do it is take 12 and hit the factor button on your calculator or whatever, but 12 obviously factors into 3 and 4, which is the 2 and 2. So 12 becomes 3 times 2 squared x squared y, and then factor the x squared plus 2x plus 1, and again, x, 1 and 1, that's pretty simple factor. Okay, what about 18xy cubed? Well, 12 did that. Let's take a look at 18. 2 and 9, 3 and 3. That gives me 3 squared times 2 x y cubed, and then x squared plus 5x plus 4, again pretty easy, plus 4 x plus 1. Now you're looking to see what's common, and then the easiest way to do x plus 1 plus x plus 1 is really to write x plus 1 squared. Okay, so we're looking for least common multiple. So we have 1 3 and 2 3s there, so that becomes, you always take the highest power, so 2 3s. 2 2s and 1 2, okay, I'm going to take 2 2s. X squared is the highest variable. Y cubed is the highest variable. Okay, x plus 1, that is common for both of them, so I'm going to take the bigger one, so x plus 1 squared, and then x plus 4. So let's just clean it up a little bit. 3 squared times 2 squared gives us 36. Then x squared y cubed stays there. Now you could go ahead and multiply this stuff out, but we're just looking for the least common multiple, so you can leave it there. Now example 2 is about adding, and we're going to take the same principle from example 1, least common multiple, kind of apply it to adding, because remember, we need common denominators. If you went 2/3 plus 1/2, you obviously couldn't add them. You would have to make the denominator 6, okay? So 3 times 2 gave you 6, so 2 times 2 is 4. 2 times 3 gave me 6, so 1 times 3 is 3, and that ends up giving you 7/6. That's the only way you can do it when you're adding like fractions. It's the same concept with rational expressions. You need common denominators. So let's start off by factoring. X over x minus 1 plus, I can't factor the top, 2x minus 1 over, well, let's find an AC number. 1 times 2 is 2. Obviously, that's just going to be 1 and 2. Same signs, and we need a -3, so it's -1 and -2. So I end up with x minus 1 times x minus 2. So in order to get common denominators here, I need to get an x minus 2 next to this x minus 1 right here. Okay, I need to get it right next to that. So how do I do that? Well, I could multiply that by that, but remember, when I change something, I've got to go ahead and multiply both top and bottom by x minus 2. Okay, just like when I changed the 3 to the 6, I multiply the 3 times 2. What else do you have to do? You have to multiply the top by 2, right? That's how you got to the 4. Same difference here. So what I end up with is x times x minus 2 over x minus 1 times x minus 2 plus 2x minus 1 over x minus 1 times x minus 2. Now, the numerator you can leave factored out, so you're always there. Plus, that'll come into play as we move on if we can factor cancel later. So just leave the denominator factored. So you end up with x minus 1 times x minus 2. That's fine. The top, now let's go ahead and distribute this through. That gives me x squared minus 2x plus, and then 2x minus 1 over x minus 1, x minus 2. Now, when I add these together, notice how when I added 4 6 and 3 6, the denominator still stayed 6. It didn't change. It's going to be the same thing with the rational expressions. Get x minus 1 times x minus 2 on the bottom. Nothing different. But now we're going to combine the numerator. So x squared, there's nothing common, so I'm going to add that. And I like to cross them out as I go. Negative 2x plus 2x is gone. Okay, so that's going to cancel. Nice job. Then we got that minus 1 sitting there. Once we get it to this, Now we want to go ahead and simplify. Just like you reduce your fraction. This can't really reduce, so that's really not a great example for that. But if you had something that ended up like 4/8, you would still reduce that to 1/2 at the end. So we're going to do the same thing here. So let's factor the top. Difference of perfect squares, x plus 1, x minus 1, over x minus 1, x minus 2, cancel, cancel, and end up with x plus 1 over x minus 2. Final answer. Remember, we need to state restrictions on our domain or our variable. So what can't x equal? Again, go back to find anywhere in the denominator here. We have an x minus 1 and an x minus 2, so x can equal 1 or 2. What about subtracting? It's the same concept. You still want to factor cancel or factor out the denominators so you can see what you need to accomplish or how I can get common denominators. So x plus 2 on top, that stays there. There's not a factor there. X squared minus 2x, I can pull an x out. That gives me x minus 2 minus x plus 2 is going to stay up there over, well, 2x minus 4, I can pull a 2 out, and I'm on with x minus 2. Now you have to ask yourself, what is the one on the left missing and what's the one on the right missing? Well, if you look in the denominator here, you have x and x minus 2. Here you have a 2. So I need to get a 2 into this one, so I'm going to multiply by 2 over 2. What am I missing here? Well, same kind of concept here. I'm missing the x now over here, so I'm going to multiply this by x over x. So multiply the stuff through. On the top, you get 2x plus 4. On the bottom, you end up with just 2x times x minus 2, and I would leave it factored. It makes your life easier. Multiply the x through, and I would go ahead and multiply the numerator, so you get x squared plus 2x. And go ahead in the denominator, 2x, x minus 2. Now, when they match, go ahead and subtract. Now remember, you're subtracting this, okay? Not adding. So all you want to subtract everything. So the first thing would be an x squared, so that's going to be negative x squared. 2x minus 2x, again, is gone. Great. 4 minus 0 is just positive 4. Over 2x, x minus 2. And they love throwing these negatives at you because it's kind of confusing. But if I pull a negative out of the top, negative times, what happens? I get x squared minus 4. Now you have a difference of perfect squares. So let's factor the top. Leave the negative out there. That's going to factor into x plus 2, x minus 2, all over 2x times x minus 2. Well, x minus 2 is cancel. My final answer here is going to end up being negative x plus 2 over 2x. Restrictions on my variable. Well, let's look for everything in the denominator. Well, you have this 2x sitting there, so it can't be 0. Because remember, 2x can't equal 0. You get x minus 2 can't equal 0. So the only one will be 2. Example 4 is about complex fractions. And again, we're still looking for common denominators, but to make my life easier, just look at all the denominators. I have x, I have y, and I have y. So what I want to do is multiply both of them by xy. Why? Because that's my least common multiple of all the denominators in the top and bottom. So what does that become? When I multiply, let's distribute 1 over x times xy plus x over y times xy, because I'm distributing to both things, over, same thing on the bottom, 1 over y times xy plus 1 times xy. So what I end up with? Well, this cancels. I end up with y. Okay, what cancels here? The y's cancel. I end up with plus x squared. Now let's look at the bottom. What cancels here? Oh, the y's cancel. So I end up with y here. And then I'd have nothing there. Okay, technically you could pull a y out. You end up with y plus x squared all over y times 1 plus x. But nothing cancels, so any way is fine. I would just kind of leave it like that.